All right, in this video, we're going to use everything we learned about arithmetic series in our first video on 11.2 to solve page number 57 on page 664, which states domestic bees are make their honeycomb by starting with a single hexagonal cell, then forming ring after ring of hexagonal cells around the initial cell as shown. The numbers of cells in successive rings form an arithmetic sequence. There it is. So this cell, if you count, has this ring has 6 cells in it, and this ring has 12 cells in it. So 6 and 12 are what we're using for our arithmetic sequence. So if we look a little bit more at this, we could say, okay, I've got term number 1, 2, 3, 4, and I've got 6 and 12 so far. So, but we've been told already that the number of cells in successive rings form an arithmetic sequence. So that means that if this is going to be arithmetic, this has got to be this difference has to be constant. The difference is 6, so this difference has to be 6. D equals 6 because it's an arithmetic sequence. So that means that our 0 term would be 0, right? This is 18, and this is 0. Now, in a way, that doesn't make sense because our drawing shows something that looks a lot like not 0. It kind of looks like a 0 term here is 1. But modeling like the whole sequence, if we put plus 1 into the thing, it would mess up the sequence. Then we'd have 1, 7, 13, and we don't want that. We have 6, 12. So our sequence is based on this 6, 12, 18. It's based on having a 0 term of 0. And why do I mention that? Well, because the first thing that this question asks us is, write a rule for the number of cells in the nth ring. Well, how do you write a rule for an arithmetic sequence? Well, basically, first, an arithmetic sequence has a linear rule. It has a slope and a y-intercept. And the y-intercept is the 0 term. So the first thing you do is you find that 0 term, and then the slope is d. The common difference, what it's changing by, that's the slope, and you plug those things in. So back in our example here, we say our 0 term is actually 0, and our common difference is d. So therefore, our rule has to be is going in mx plus b form, and the slope is the common difference, or 6. And instead of using x, we use n because it's the term number. And my intercept is 0, so that's just the rule is 6n. So that's the answer for A, is 6n. And then the next question says, what is the total number of cells in the honeycomb after the 9th ring is formed? Hint, do not forget to count the initial cell. So what we want to do is look at, okay, I want to use these formulas that I used, that I learned the last section, these formulas here. And remember, to use this formula, I needed to know the last term. So to find the last term, I needed this formula. So they're asking me for the first 9 rings. So I need to know how many cells there are in the 9th ring. So it's A9 equals the first term, 6, plus the common difference, 6 times n minus 1. N is 9, so it's 6 plus 48. 8 to 9 is 54. So the first A1 is 6, A9 is 54, and now we can plug that into this formula. The sum of the first 9 layers is 9 is n, but it's 6 first term plus 54. So that's the first ring and the last ring times n over 2. And it turns out that if you do your math, you do your calculations, you end up getting 270. But then we have our hint. Don't forget about the initial cell, so we have to add 1. So my actual answer should be 271. 271 cells. All right, I'll look forward to your questions in class tomorrow.